Background. Mathematical models are an integral part in the sciences and engineering. Their sole aim is to aid in the understanding of physical phenomena. Such models yield an equation that contains some derivatives of an unknown function. Such equations are referred to as differential equation. Example: free fall is one case in which an object, when released from a certain height above the ground, falls under the force of gravity. Newton's second law states that the mass of an object times its acceleration is equal to the total force acting on it. Applying this law to the falling object, we obtain the equation m times the second derivative of height equals negative mg. Here m is the mass of the object. The second derivative of h with respect to t gives the acceleration of the object. G is acceleration due to gravity, and negative mg is the force due to gravity. We divide both sides by the mass m to get the second derivative of h with respect to t is equals to negative g. Then we integrate with respect to t to get the first derivative of height with respect to t is equals to negative g times integration dt, and that is going to give us negative gt plus the constant of integration c1. Again integrate with respect to t to get h is equals to negative g times t square over 2, which is the integration of t dt, plus c1 times integration of dt. So finally we get negative half gt squared plus c1t plus c2. The constant of integration c1 and c2 can be obtained if we know the initial conditions, such as the initial height h of 0 and the initial velocity dh over dt at t equals to 0. Different areas where differential equations arises. Psychology. Model for learning of a task. The first derivative of y with respect to t whole divided by y times 1 minus y whole raised to the power of 3 half is equals to 2p divided by square root of n. Here y is the learner's skill level. P and n are constant that depends on the individual learner and the nature of the task. Kirchhoff's law. Used in the study of electric circuit consisting of a resistor, an inductor and a capacitor run by an electromotive force. L times the second derivative of q with respect to t plus r times the first derivative of q with respect to t plus 1 over c times q is equals to E of t. Here L is the inductance, R is the resistance, C is the capacitance, Q is the charge on the capacitor, and E of t is the electromotive force. Terminology. Suppose an equation involves the derivative of one variable with respect to another. The former is called a dependent variable and the other an independent variable. That is, the second derivative of x with respect to y plus alpha times the first derivative of x with respect to y plus beta x is equals to 0. X is the dependent variable and y is the independent variable. Alpha and beta are the coefficients. Partial of u with respect to x minus partial of u with respect to y is equals to x squared plus 3xy. X and y are independent variables and u is the dependent variable. When an equation involves only ordinary derivative with respect to a single variable, we have an ordinary differential equation. The second derivative of x with respect to y plus alpha times the first derivative of x with respect to y plus beta x equals to 0 is an example of an ordinary differential equation. A differential equation involving partial derivatives with respect to more than one independent variable gives a partial differential equation. Partial of u with respect to x minus partial of u with respect to y equals x squared plus 3xy is a partial differential equation. Order and degree. The order of the highest order derivative present in the equation defines the order of the differential equation. This differential equation is a second order ordinary differential equation. This equation is a first order partial differential equation. The degree of the highest order derivative present in the equation defines the degree of the differential equation. So this equation is a second order ordinary differential equation with degree 1. This equation is a first order partial differential equation with degree 1. Linear and nonlinear differential equation. Lines and planes are easier to visualize as compared to non-linear objects such as cubic curves and quadric surfaces. That is, if we know 2 points on a line, we can find all the points on that line. Y minus y1 is equals to y2 minus y1 divided by x2 minus x1 whole multiplied to x minus x1. This is the 2-point form, where x1, y1 and x2, y2 are 2 points on that line. In the similar vein, linear differential equations are more amenable to solution as compared to nonlinear ones. Ax plus by equals to c, equation of a line. Ax plus by plus cz equals to d, equation of a plane. The variables xy in the equation of a line and the variables xyz in the equation of a plane appear in additive combinations of their first powers only. To be precise, a differential equation is linear if it is expressible in the form an of x, the nth derivative of y with respect to x, plus an minus 1 of x, the n minus 1 derivative of y with respect to x, plus up to a1 of x times the first derivative of y with respect to x plus a0 of x equals to f of x, where an(x), an minus 1 x up to a0 x and fx depend only on the independent variable x. Any differential equation that is not linear will be termed non-linear. For example, second derivative of y with respect to x plus y cubed equals to 0 is a non-linear differential equation because of the second term y cubed. But y cubed times differentiation of x with respect to y equals y cubed plus x is linear, even though we have a y cubed term. Arrange the terms y cubed times differentiation of x with respect to y minus x is equals to y cubed. Dividing both sides by y cubed, we get dx over dy minus x over y cubed equals to 1, which can be rewritten as dx over dy plus negative 1 over y cubed multiplied to x is equals to 1. If we compare it with a1 times dx over dy plus a0 y, x is equals to f, which represents a linear differential equation. Second derivative of y with respect to x minus y times derivative of y with respect to x is equals to cosine of x is non-linear. Now that is because if we write it in the standard form, a2 of x times second derivative of y with respect to x plus a1x times derivative of y with respect to x plus a0x is equals to f of x. Here, a1x is equals to negative y, which is not a function of x, hence non-linear.